Hi, unfortunately we're interrupted, but we can continue right now. And now we're going to introduce another possible transformation. Now look, what if y is equal to 1 over x minus 1? Okay, first thing we should notice here is that at the point we need to cut out of our domain is no longer 0. Because look, if it's 0, x is 0, it's negative 1. But now we don't want the denominator to be equal to 0. So x must be different than 1. And our domain is, in other words, real numbers without 1. Okay, so look, if we're going to be filling the table over here, for the new function, then the first thing we need to do is to cut out this point. Right? Well, we clearly see that when x is 1, we cannot find the value of the function. But now, let's see what happens in other points. Now, if x is 2, we get 1. Right? 2 minus 1 is 1, and so we get 1. If x is 3, you will have 1 over 2. And when x is 4, we will have 1 over 3. Okay, let's check a couple other points. If x is 0, we've got negative 1. If x is negative 1, we've got negative 1 over 2, right? If x is negative, if x is negative 2, we will have negative 1 over 3. Then negative 1 over 4, negative 1 over 5. And look, even at this moment, you should be able to see what has happened. Look, each value that we had on the whole numbers, 1, 2, 3, 4, 0, we clearly see that they moved one place to the right. And look, this is basically how this transformation works. If I take and subtract some value from x, but not from the entire function, just x, we are moving the function 1 unit to the right. Okay, what is the easiest way to do it? No, of course, we still should remember that the asymptote that is here will still exist, right? So the easiest way to do it is to move the asymptote to the point 1 and draw a new one. Look, now all we've got to do to draw this function is to treat this as y-axis and draw more or less the same shape. And the same goes here. Okay, but look, based on this simple example, we can conclude another rule. If we have a scenario in which we have y equals f of x minus b, where b is positive, then what we should do, we should move the function to the right by b units. So look, if we subtract a number from x, we will be moving to the right. And look, it also works in the opposite direction. If we would have y equals to some f of x plus b, again with b we would have to move the function to the left by b units. Okay, so now that we've established this rule, I think we are ready to tackle with more complicated functions. Okay, so let me now show you the easiest way, in my opinion at least, to deal with the function, with the reciprocal function with many transformations. Okay, look, imagine that the function we need to deal with is y equals, let's just say, 1 over x plus 1 absolute value minus 2. Okay, this might seem like a problematic function to draw right away, but maybe we can use everything that we learned about the transformations and do it step by step. And look, we do it like this. At the beginning, we should start with the function 1 over x, because we know how it looks like. Then, we should make the function more and more complicated in each consecutive step. Okay, so, and we start with the things that are usually the closest to x. So the first thing I will do here is to find this function, then absolute value of this function, and finally, in the last step, we subtract 2 from the function. Okay, so we got the final result, the result that we wanted to obtain from the very beginning. Okay, so let's do it. First, of course, we start by drawing Cartesian coordinate space, and we start by drawing function y equals 1 over x. Look, the next thing we should do is to add 1 next to x. We remember, if we subtract from x, we move to the right. If we add, we must be moving to the left. So if I have plus 1 here, I need to move the function by 1 unit to the left. So, the easiest way, of course, to do it is by moving the asymptote from the y-axis. Okay, and now I just need to draw exactly the same function, just 1 unit to the left. Okay, now, in the next step, what am I supposed to do is to take absolute value. Absolute value, of course, transforms positive numbers to the same numbers, right? Positive numbers are unaffected. So, what you see is that everything above x-axis must remain the same. So we can draw over this line. Now, everything that used to be negative now should become positive. So we will obtain mirror reflection with respect to x-axis. Okay. Now, finally, the last step, we need to subtract 2 from the function. Okay, this time we are doing a subtraction from the entire function, so we will be moving up and down. Of course, because we are subtracting, every value should be 2 units lower. And of course, the easiest way to obtain this result is to take the imaginary asymptote that is in the horizontal axis and move it 2 units down. And look, now we draw the same function as the orange one here, but it's going to be 2 units lower. And here. Okay, and look, now what would happen here if I now decided that this is not enough? Let's just say that we want to also take absolute value of this. Then let's move to the next function. The next function we would have here would look like that, right? So, what we need to do now is to take this function and take absolute value of it. And look, again, we remember absolute value keeps every positive value unchanged. Right? And the same is true for 0. So this part would be the same. Now, what about this part? Look, now we need to have a function. Now, those values over here should be made positive. But look, at a very specific situation over here, those values over here are getting closer and closer to -2, but never reach. So now, if we are taking absolute value of them, then those values should be somewhere around here. They should be getting closer and closer to 2. What is the easiest way to draw that? Well, we should draw an asymptote of 2 over here, and we draw those over here and over here. Okay, so now let's try again with something slightly more involved. But again, we will be using the consecutive steps, which will make our job very easy as long as we know how every basic transformation works. Okay, so now let's say that the function we got is a negative absolute value of 1 over negative x minus 2 minus 1 plus 2. Well, as you see here, we will have plenty of transformations, but still going through all the basic rules that we've established all transformations, we will be able to draw it pretty easily. Okay. So again, we're going to start with 1 over x. Then, the next thing we should draw is probably 1 over x minus 2. Then, we should take absolute value of it to obtain absolute value of x minus 2. Then, in the next step, we should probably get rid out of this minus. Unfortunately, this one is going to be a little complicated. So we will have minus 1 over x minus 0. Then, in the next step, the function that we should deal with is probably the one involving also -1. Then, the next step, we should take absolute value of this. Okay, unfortunately, I think I'm running out of colors, but we'll see. Okay, we've got negative 1 over x minus 2 minus 1 absolute value. Then, in the next step, maybe just bring this the best, but I'm running out of color at the moment. Okay, so we've got now minus absolute value minus absolute value 1 over x minus 2 minus 1 absolute value, and finally the function that we actually want to get here in the last step is when we get this function and we are moving it up by 2. So look, this function is definitely somewhat complicated. We've got 1, 2, 3, 4, 5, 6, 7, 8 steps. But still, in each step, we'll have to just use one simple transformation. Okay, so let me start by drawing coordinate space and 1 over x. Okay. Now, first thing we need to do, we need to subtract 2 from x, which means we are moving the function by 2 units to the right. The easiest way, of course, to do it is by drawing a new asymptote over here and just draw this function in a new location. Then we need to take absolute value of this expression, which means that this part remains the same because it's positive, but this part is negative, so we obtain mirror reflection. Now, in the next step, we should have minus, so negative of our previous function. Because it's all positive, it will now become all negative. So we will get this part of the function actually goes back to its original location. This part goes over here. Then our another transformation requires us to take this function and move it 1 unit down. Again, the easiest way to do it is by drawing an asymptote on 1 and moving grid and drawing grid function as if those were the axes. So we will get like this and like this. Okay, then in the next step, we need to take absolute value of this entire expression. So, everything we've got is negative. We need to make it positive. And look, over here it's getting closer and closer to -1, right? So, if it's getting closer and closer to -1, then on positive value, it will be getting closer and closer to 1. So again, we start by drawing an asymptote on 1, and the function we've got will be over here. Then, in our next transformation, we need to impose minus in this. What does it mean? Well, it means basically that we are getting, because everything here is positive, we are going back to our previous location. And we are over here. Now, finally, we need to move this function 2 units up. If we want to move this function 2 units up, what do we need to do? We should take this asymptote, move it 2 units up, so we will get on this asymptote that we used previously. And now we are drawing this function with respect to these 2 asymptotes. This one we already have, but let me just draw it again because this is the final version. And now the function should look like this. I'm sorry. Okay, and it is ready. Of course, you will be practicing these transformations a little bit more in your workshops, but I believe that it gives you the gist on how to do it. And it doesn't really matter how complicated the function is, as long as we follow all the steps, we will always achieve our goal of drawing the most complicated functions. We just need to do it slowly. Of course, with time, when you practice it a lot, you usually can do a lot of these steps at once. But of course, this is an appropriate way to do it. Okay, so there is one more thing I wanted to show you associated with transformation of reciprocal function. This transformation will be very different to what we saw. Because now, what I'm going to do is to add square on x. But before we do it, let's go back to the table. Well, we already know this function very well. So let's just use a couple of values. We've got -3, -2, -1, -1 over 2, -1 over 3, 0. 1 over 3, 1 over 2, 1, 2, 3. Okay, so we remember, of course, all the values for this function. -1 over 3, -1 over 2, -1, -2, -3, sorry, x 3, 2, 1, 1 over 2, 3. Okay, and of course we know how to draw it. I know very, very well. Okay, and we know that this is the point 1, 1, and this is the point 1, 1, -1, -1. Right. Now what I wanted to do is to draw the function y equals 1 over x squared. Look, what about the domain? Well, domain remains the same, because the only value we cannot put instead of x is 0. So definitely x still can be 0, and our domain is still real numbers without 0. But let's see now what is going to happen to other values of this function. Now, here we still have x, but like, of course, at this point, 1, if x is 1, y is 1. If x is 2, though, we've got 1 over 4. If x is 3, sorry, it should be 1 over 3 over here. If x is 3, we've got 1 over 9. Now, what about if x is 1 over 2? Well, 1 over 2 to the power of 2 is 1 over 4. When we divide by 1 over 4, we get 4. So here we will get 9. Okay, so now let's go to negative numbers. Here we will have 1. Here, 1 over 2. We will have 4. We will have 9. We will have 1 over 4. We will have 1 over 9. So two things are changing over here. First, because we've got square, all the values are becoming positive, right? So we get that this part, about this part of the function, we we will have it somewhere here, but it will have a different shape, slightly, right? And over here, we need to move it over here. Now, but how will the shape change over here? Look, we can notice two things. Now, as I'm getting closer and closer to 0 from 1, the values of this function are growing faster, right? On the other hand, when I'm moving away from 1, those values are declining faster. So, how should I draw it? Well, here, it should be steeper. Well, it should be steeper everywhere, right? Like this. And, of course, the same we will have over here. Okay, now I hope with this example, after you would be able to draw functions like 1 over x to the x cubed, x to the power of 4, using the same reasoning. And look, if I would have here x cubed, again, negative values would be permitted, so we would have a function that is somewhere around here in the negative part, right? If we would be x to the power of 4, again we would be above x-axis, and the slope, the function, would just get steeper. Okay, so I think this is enough about reciprocal function and the transformations. In the next video, we will learn about exponential function.